All right, so the next lesson is on something called linear systems. So first thing I want to do here is just kind of explain what a system is. All right, so a system of equations is when you have two or more equations. And basically what we want is, as a goal, is we want to find a certain point or a certain value for x and y such that it's true for both equations. So that's the goal. So I'll write that down here. So the goal is to find a point, so x, y, such that it is true for both equations. All right. So there's various methods. There's various methods to solving these systems. All right. So we could actually use algebra. We could use algebra. And there's actually different methods within the scope of algebra to find solutions. Or we can just solve them by graphing, which is basically the only way that you guys have to worry about how to graph it. All right. And the beauty of this is that we're actually allowed to use Desmos to graph these. So it's very quick and pretty straightforward. All right. So basically what I'm going to do here is I'm going to graph this line. All right. So y equals 3x plus 1. And I'm going to graph this line, y equals negative 2x minus 4. Okay, so I'm going to graph both of these lines on Desmos, and we'll see what happens. All right. So again, y equals 3x plus 1. And the other line would be y equals negative 2x minus 4. All right, so let's just close up that. All right, so these are the two lines. All right, the red line is has a positive slope, so I believe that's a 3x plus 1, and the blue line has a negative slope, so that one's the y equals negative 2x minus 4. So it's pretty straightforward. All right, so wherever these two lines cross is your solution. Right, quite simple. Right, so I'm just going to click on Desmos here, and basically Desmos says that it's going to these 2 points are going to cross at -1, -2. So that's your answer. It's that simple. All right. So the solution, the answer, once we graph it, is at the point -1, -2. All right. So now the other thing, though, that we're going to be asked to do here is we're going to be asked to check your solution algebraically. All right, so this is how we get the solution. All right, we're going to graph this line, and where they cross is your actual solution. But the second part here is that we want to check your solution algebraically. All right, so what that means is that we're going to take this -1, -2, and plug it in for x and y, and make sure that the left side matches the right for both of these equations. All right, so that's how basically we check. All right, so I'm just going to open up this one a little bit larger here, and I'm just going to show you here. So right now I'm going to check my solution algebraically. All right, so let's check. All right, so, and let's just number these. Okay, so that's the first equation, that's the second equation. So for the first equation, I'm going to plug in -1, -2 for x and y. Okay, so y is -2. I'm going to punch in -2 there, equals 3 times my x value, which is -1, plus 1. And I just want to make sure that the left side here matches the right. Okay, so I have -2 equals -3 plus 1, -2 equals -2. All right, so it's worked out for the first equation. Now I want to do it for the second one as well. All right, so again, I'm going to plug in -2 for y and the -1 for the x. Okay, into the second one here. So we get -2 equals -2 equals, okay, so -2 is the front there, and then I'm going to plug in -1 for x minus 4. All right, so -2 equals, so these two multiply, -2 times -1 is +2. minus 4. So negative 2 equals negative 2. All right, so this works as well. All right, so that's how you check your answer algebraically. Now, the thing about this system is that negative 1, negative 2 is the only point for which, when you plug it into both of these, the left side matches the right. Okay? No other point will work. Okay? So no other point will allow you to have the left side to match the right for both. Okay, so that's what it means to be a solution. It's basically when you take the point, plug it in for x and y into both equations, the left side matches right for both. All right, and this is the only unique solution. All right, cool. So hopefully that makes sense. So let's go on to the next one here. Example 2, explain why the following system has no solution. All right, so this one's a little bit different. So what I'm going to do here is I'm just going to plug in both of these equations and see what we get here. Okay, so first one here, y equals 2x plus 3. And the second one here is 4x. And I'm just going to punch it in that way. So 4x minus 2y equals 4. All right, so let's just see how this looks. All right, so what do you see here? Well, we see two lines that will not cross. All right, so they're parallel lines. These two lines are parallel. So there's no point here where they will cross, right? You can see that it's pretty much the same distance. So that means that there is no point that you can plug in here for x and y so that the left side matches the right. No one unique point. And it's visually, you can see that makes sense because these two lines are parallel, so they'll never cross. And so there is no point of intersection. Now, why is this the case? So when it comes to lines, right, two lines that are parallel will have, this is the key thing, they'll have the same slope. They should have the same slope, same rise over run, same rise over run. And as long as they have two different y-intercepts, then they'll never cross. All right, so to explain why the following system has no solution, what I'm going to do here is, you can see in the first line here that 2x here, so we have a slope that's equal to positive 2, right? So for the second one here, if I isolate the y and change this to y equals mx plus b form, or another slope-intercept form, it should have a slope of 2 as well. All right, so let's just see what happens here. So I'm going to take the 4x, I'm going to move it over. We get negative 2y equals negative 4x plus 4. And then what I'm going to do here is divide through by negative 2. And we get, as these cancel out, that y equals, so negative 4 divided by negative 2 is positive 2. So 2x and then minus 2. Right. So this is the second one here converted to slope-intercept form. And you can see that, yes, we do have the same slope. So slope of 2. Right. We also have, I'm just going to put a triangle around here, a y-intercept of negative 2. This one over here, we have a y-intercept of 3. So we have two different y-intercepts, right? So negative, what was that? Positive 3 for the first one, and then negative 2 for the second one, right? So if you have two lines with the same slope, but different y-intercepts, then those two lines will never cross. And therefore, the system itself will not have any solution. Okay, I'm just going to write that out here, actually. So since both lines have the same slope, but different y-intercepts, they will never cross. So if they don't ever cross, then there's no point of intersection. Therefore, there is no solution. Right? So no point of intersection, which means that there is no solution. All right, so if two lines in a system have the same slope, but different y-intercepts, then they'll never cross, and therefore there will never be any solution. All right, cool. So hopefully that makes sense, guys. Yeah, so that's those linear systems. Yeah.